All right, let's get started with Lesson 9, Entropy, Part 1. Now, before we can go any further with our understanding of thermodynamics, I need to introduce to you two new important vocabulary words, spontaneous and non-spontaneous. A spontaneous process is a natural occurring process that will occur without the need to do any work. There is a natural tendency for this process to just occur. In fact, it doesn't matter about timing. Some spontaneous processes are very fast, others are very slow, taking thousands, if not millions of years to complete. The point is the process is going to happen. It's going to occur. You don't even have to be around to make it happen. Contrast that with a non-spontaneous process. These processes will never happen. They'll never take place. No matter how much time goes by, they just won't happen unless work is done. You have to make it happen. You have to do something to force the reaction to occur or the process. For instance, let's think of an analogy. Say that you climb up to the top of a mountain and you are standing on a cliff looking down, and you have a rock in your hand and you let the rock go. Will the rock stay where it's at? Will it fall, or will it go up? What is the natural tendency? Well, you know the answer to this. Of course, the rock is going to fall. That's what its natural tendency or process that will happen. It's not going to stay where it's at, and it's certainly not going to go up. The only way the rock is actually going to go up is if you throw it. You apply energy, you apply work, you make it happen. All right? Other than that, it's going to fall. All right? Let's look at another example. We have two skiers here. One skier is skiing down the hill, the other skier is skiing up the hill. Well, what's natural? Well, obviously skiing down the hill. You're not going to ski up the hill. That's just not natural. All right? In fact, is the only way you're going to get up the hill is if you add work. You do something, you work, you climb up the hill. Whereas skiing down the hill, you're just going to go. You're going to take off and you're going to keep on going until you hit the bottom or hit a tree. All right? That's just skiing. Natural tendency. Downhill, not uphill. All right? Here are some other natural occurring processes that are spontaneous. A waterfall runs downhill. Never runs uphill. That's ridiculous. A lump of sugar is going to dissolve in a cup of coffee. That's natural. All right. It's also going to dissolve in water naturally. All right. Water is always going to freeze at 1 atmosphere below 0 degrees C, or ice is going to melt above 0 degrees C. Heat always flows from a hot object to a cold object, never the other way around. Gases expand. If iron is exposed to oxygen and water, it's going to naturally form rust. We don't have to do anything to make these processes occur. They're going to occur on their own, with or without us. We don't have to be around. Now, time is not a factor here either. Again, some of these processes are fast, some of them are slow. The point is they're going to happen. They're going to occur. Now, let's look at an example of gas particles. Here we have an experiment or a demonstration of a container, a glass container that is full of gas particles. On one side of the container, we have the gas particles, and on the other side it's empty. Now, that means that the concentration of gas particles is much higher here and is low on this side. Now, if I open up this stop container, what is the natural tendency for these gas particles to do? Well, they're going to move. They're going to move from a high concentrated area to a low concentration area. That's just the natural tendency. And they're going to do so until these gas particles are randomly distributed evenly throughout both sides of the container. Again, they're going to move until they're randomly distributed throughout the container. Are you ever going to see this opposite process occur? Absolutely not. You're never going to see a random bunch of particles that are distributed evenly throughout the container go to one side and leave the other side empty. This just simply will not happen. All right? So what exactly makes a process spontaneous? What is the driving force? How do we determine if something is going to occur or not occur? Well, I want to introduce to you the term entropy. Entropy is the key to understanding spontaneity. If something is going to happen or not. All right? Here's the definition. Write it down in your notes. All right? But the key word here in this definition is the word disorder. All right? Entropy applies to disorder. All right? Either a system is going to create a more ordered universe, or it's going to create a more disordered universe. Well, it turns out that nature has a natural tendency to create disorder or randomness. All right? In fact is, if we look at some important points here, this first point, matter and energy have a natural tendency to disperse and become more disordered. This is the key in understanding. A process will occur if randomness or disorder will happen or take place in the universe. If the universe becomes more ordered, the process just won't occur. All right? So entropy is simply a measurement of disorderness in the universe. All right? And essentially the degree of disorder of a system can be determined by the entropy, which, by the way, entropy is symbolized by the letter S. Okay? We use S to represent entropy. We say ordered states have low entropy, and disordered states have high entropy. Well, if we want a process to occur, we want to have high entropy. We want the entropy to actually increase, not decrease. A decreasing entropy system just simply means that the process is becoming more ordered and it's not very favorable. Let's take a look at another analogy. Let's think about your bedroom, for instance. Is it easier to keep your room disordered, or is it easier to keep it ordered? Well, I think you know the obvious answer to this. In order to keep your room ordered, you have to work. You have to clean up your room. It's easier to create a disordered or a messy room. In fact is, all it takes is for you to move a few objects around in your room, throw your clothes on the floor, your bed, leave your shoes hanging around. It's easier to do this. It's easier to make a mess, in other words. And making a mess is the natural tendency for the universe to go. Now, don't use entropy as an excuse not to clean your room. Don't go, Mom, it's just natural for my room to be disordered. That's the natural way of things, okay? It's not going to fly with your mom, all right? Yes, you're going to actually have to do some work. You're going to have to clean your room. You're going to have to go against the natural tendency of nature and keep your room ordered. That's just going to have to be the way it is, okay? But the universe as a whole wants to move towards this disordered or random state in nature and increase the entropy of the universe. Hence brings in one of the most important laws in nature, and that is the second law of thermodynamics. The second law of thermodynamics simply states, in any highlight this. In any spontaneous process, there is always an increase in the entropy of the universe. All right? What does this mean? Entropy, or what we can say the change in entropy of the universe, okay, Remember, delta means change. So the change in entropy of the universe, if it increases, if it goes up, then the process will be spontaneous. It's going to naturally happen, all right? However, if the entropy of the universe goes down, then the process won't happen. It just won't occur. No matter how much time has gone by, it just won't happen or take place. Now, we actually have some equations, or an equation for this, that we need to consider, all right? So the change in the entropy of the universe can be found by knowing the entropy change of the surroundings and adding it to the entropy change of the system. And in the second part of this lesson, we're going to learn more about how to determine the calculations for this equation, all right? And we're going to come back in the second part and understand the second equation that you see here listed, all right? But for now, this is going to end the first part of this lesson. Please review your notes really well. Go back and relook at this lecture video if you need to. The honest idea here is that you really need to know the difference between spontaneous and non-spontaneous. You need to understand the idea that if something is spontaneous, it's going to increase the entropy of the universe. In other words, the universe is becoming more disordered, more randomness is going to occur, and order goes away. Okay? That's the bottom line. That's it in a nutshell. All right? So this is it for now. Please review the next part 2 of this lesson, and that's it.